So we want to welcome everyone to our webinar on, this is a review of the December 24th to 25th high wind and flooding. That was the mild air we had come in on Christmas Eve and Christmas Day. So presenting with me is Frank Nocera and Hayden Frank, who helped put the presentation together. So we will get right to it. And Frank, I believe you're leading off.
All right, thank you, Joe, and hopefully everyone could hear me okay. Good morning. Now let's take a look at the surface map leading up to this event. Here's the WPC Day 3 surface prog for Christmas morning, 12Z Friday. And you can see apparent low pressure tracking well to the northwest of New England. So obviously no P-type issues. We're looking at all rain here. Deep southerly flow, really an impressive warm sector for late December. We were expecting dew points to surge through the 50s and perhaps even near 60. And then that combined with, a strong front moving in from the west with that type of warm sector and strong frontal convergence, there was the expectation that we maybe could be dealing with a fine line of low top convection that would just enhance the wind threat. All right, looking at situational awareness tables. I know many of us use these situational awareness tables, very, very helpful. This one here is the European ensemble, and I believe this is password protected, so I believe only the Weather Service folks have access to this, although maybe some of the private vendors do sell this, but I know the NAIFS is public domain, so everyone has access to that. So looking at here, and hopefully, what jumps out at you when you're looking at Day 4, Friday, Christmas, the 25th here, the anomalies are like 4.5 with the wind and even the precipitable waters, and the IVT is almost 8. So I mean, that's really a good indication for excuse me, that this is really a high-end event here that we're looking at. And as the text shows you here, this indicates the potential for a highly anomalous precipitation event. Okay, sorry, lost I don't know if I lost internet there or something.
Oops, sounds like we might have lost Frank. So Hayden, maybe I'll just take it over in the meantime. So from going through some of the ensembles, this is the NAIFS. I'm looking at climatological percentiles. This is the 850 meridional wind, so the north-south component. And kind of what was shown in the table before, you can see a large deviation from climatology, almost up near the max here with the southerly jet for the period. And then looking at a couple of other the extreme forecast indices. These are from the European model, but I believe that the GEFs and the NAIFs were similar too, showing higher percentile wind gusts expected across much of the region, as well as some of the Cape as well, showing the instability. Although certainly the greater instability, departure was south of our region, but just enough nosing up into our area to perhaps support a fine line of convection. And also looking at the QPF, not surprisingly, this was up near the top of the charts based on the European forecast across much of the region ahead of the cold front with the deep southerly flow. So we'll get into, Hayden will get into that aspect a little more later. So I'm going to start off we're going to split this into two sections, looking at the wind impacts and then also forecasting the heavy rainfall and flooding. I'm going to start with the wind, and then I'll pass it off to Hayden for the next section. So, obviously looking farther out in time, we want to look probabilistically. So a lot of what we look at are some of the probabilistic forecasts, whether it's wind or QPF or even snow. So obviously here we're seeing some pretty high probabilities. These are 10-meter winds depicted of gusts of greater than 50 knots, looking at two different model runs, and obviously fairly high probabilities. I'm sorry, same model run, different times. This is 12Z on Christmas morning, and then 18Z you can see has worked its way offshore. But, for 4 days ahead of time, these are fairly high probabilities. You're up over 90% in both cases. So that's implying that there's, pretty high certainty in a potential high wind event here. Looking at some of the deterministic model data for this is out 84 hours on the NAM. We don't always trust the NAM so much outside of 48, but it had a pretty clear signal here. Highly anomalous southerly low-level jet, 90 to 105 knots. And as listed here, our concern for reaching high wind warning criteria, that's the 50 knot, plus gusts, really grows when our 850 winds in this situation, exceed 85 knots. And of course, you need to consider things like pressure falls, strength of the inversion, which we'll get into. That was a key player here. And also, any heavy precipitation or convection that could bring down some of these winds. Going down a little further, this is the 925 millibar level. And again, not surprisingly, we've got a pretty highly anomalous southerly jet, 75 to 95 knots. Moving off the coast. And in this case at 925, we look for 75 knots or higher for high wind potential. And then as we drew even closer, even the higher res models and ensembles, we're picking up on this feature. This is the HREF, which we really like inside of 36 hours to really nail down some of those details. And this is an 11-hour forecast. This is the 0Z run from the 25th, and good core of 80 to 90 knot southerly winds crossing southern New England during the morning hours. So the main concern here really had to do with temperature. You can see this forecast was from the HRRR. It's a 12-hour forecast showing temperatures, well up into the 50s, 59s, a bunch of those you can see here across the region at 12Z on Christmas morning. And really the challenge was it going to become warm enough for us to break that low-level inversion and mix even more wind down from aloft. So we'll look at some of the soundings here to kind of help with that problem. And just looking at the dew points, mid-50 dew points and Christmas morning, that's quote unquote fairly tropical for late December. So we're going to look at some of the NAM cross sections here and also the GFS. First of all, this is for New Bedford. And you can see clearly, there's a lot of wind just off the deck, 50 to 60 knots down to about 1,000 feet here. But notice in the time, and time goes from right to left, a very sharp drop off in the wind. This is roughly after about 15Z on Christmas morning. And that's actually what happened. We had strong winds in the morning and they cut off pretty quickly as the line of showers moved offshore late morning and early afternoon. So that was a pretty good forecast by the NAM. You can also see the GFS had a similar signal, lots of wind, even a little bit stronger. The 50 knot winds are a little bit below, down to about 500 feet, but then a very sharp cutoff as we reach about 15Z on Friday. Now, the main concern here was the strength of the inversion. And, this was really where we, had most of our forecast concern. Pretty sharp inversion just above the surface here on the NAM. Again, this is New Bedford. 12Z Christmas morning. Let's go back to that. And you can see not a lot of mixing, a very sharp inversion just off the deck, and it's showing mixing potential 28 to maybe 34 knots at most. But you can see just above the inversion, 50 knots is sitting right there, and even 60, 70 knots a little bit above that. If we look at the GFS, it's got a little more mixing. It's a little drier, a little warmer, so it's certainly mixing a little bit deeper, almost up to about, say, 975 millibars or just above that. And you can see the mixing on BuffKit showing 48 knots as kind of an average, but potential for 60 knots. And even above that, we're just about at 70 knots there. So, you make this sounding a little bit warmer, maybe to the middle 60s, and you're certainly able to mix much more of that wind down. So really, this was a case where a degree or two of warmth would really make all the difference. So as I mentioned, here's the two soundings kind of next to each other. Just depends on the surface temperature. GFS was a little warmer, a little drier, had a little bit deeper mixing than the NAM, as you can see here. So, if you're in the hot seat, what do you forecast? Do you go more conservatively with this, 28 to 34 knot gusts, or, a little more higher because of the potential, maybe mentioning 60 knots? And we kind of leaned a little bit more this way, I think. Just because we thought there was going to be a little bit more warmth, but also, kind of as a more reasonable scenario, but obviously a big effect on wind impacts. In areas farther to the north, where we had some snow cover still, and it would take a while to erode, say as you got up to northern parts of Worcester County, this was really the result because you had all of that low-level cold holding on because of the snowpack, so the inversion was able to to maintain itself. Whereas Rhode Island, most of eastern Massachusetts, you had much better mixing in those areas where it was able to warm up. The snow cover eroded more quickly. So this was a kind of our last call forecast, just to show briefly what we were expecting. You can see strongest winds, Cape Ann down to the Cape Cod and the islands and along this immediate south coast, and a pretty quick drop off as you head further inland, at least on the sustained wind. And gusts were a little more, we were a little more on the higher end. Again, just not sure of how warm it would be, but certainly our confidence we messaged was highest across parts of Connecticut, Rhode Island, and eastern Mass, where we knew it was going to at least reach the low 60s. This was kind of more of a 50-50 proposition, just because we didn't know how much warmth there would be. And certainly we were confident in less warmth farther north across northwest Mass and north central Mass. And just also, this was a significant impact for our marine community. Storm force winds, 60 to 65 knots were anticipated, and as a result, driving seas up 15, 20, even 25 feet well offshore. So this actually had a pretty significant impact on things like ferry services to the islands, and certainly for the offshore fishermen. So just to kind of show what we had on the coastal waters, the southerly winds were blowing over the colder ocean, so not a lot of mixing, but still, we had some areas, solid gale force gusts, over 40 knots. Some areas did reach marginal storm force. This is off of, I believe, just south of, I'm not sure if this was probably Duxbury, 52 knots, but a lot of widespread 40, 50 knot gusts on the coastal waters. But again, it was more difficult to break the inversion there. Across, the interior, temperatures did warm into the low 60s, even, 64 there in Norwood, which resulted, less mixing, certainly in these areas where it was 60 or 62, a little bit more mixing down here, but really not seeing widespread mid 60s, which really would have brought much more wind down and would have resulted in much more wind damage across the region. This is just a quick look at some of the reports we had. You can see Hull 63 miles per hour, but for the most part, anywhere 45 to 55 miles per hour kind of did it. We did have a couple of exceptions, Blue Hill being elevated 67 miles per hour, and that one station in Duxbury had 68 miles per hour. But for the most part, 45 to 55, a few gusts to the lower 60s, even over at Bradley, able to reach a 62 mile per hour gust. Now, looking at the observed soundings, these are from Chatham, 0Z on the 25th and 12Z on the 25th. You can see the presence of a very strong low-level inversion here with, a lot of wind just above, but even some wind, close to the surface. And what I'll do is the next one, we're zooming in here. This is the 12Z sounding on the 25th. And you can see here, the inversion gets just above 1,000 millibars where the black line is. And there's a lot of wind above, but right at the inversion level, there was about a 75 knot wind out of the south, equal to about 86 miles per hour. So the peak gust we saw there was 68 miles per hour in Duxbury, which is about 80% of that maximum wind. And as a result, the impact wasn't as great as we had anticipated. Still a number of power outages, and you can see a few communities here were hit relatively hard, but overall, the number of power outages, here 7,000 during the morning, certainly far less than we've seen with other events. So with that, I'm going to pass it over to Hayden, who's going to talk about the forecasting the rainfall and the snow melt, as well as the resultant flooding. So Hayden, go ahead.
All right, great. Thank you, Joe. If there was ever an event with the wind to underperform, that was it, given it was Christmas morning and the rough 2020 we've all had. So that was kind of a blessing in disguise there. But going into the rainfall from this system, this was something that was well advertised several days out. But one of the things, we have to put together for these events is you have the rain, and usually when we get our river flooding, it's going to be two significant rain events back to back, or in this case, a significant rain event combined with significant snow melt. And that's what we're going to kind of be looking at during the second half of this presentation. And looking at river ensembles, we look at a lot of weather ensembles, but we'll get into some of the river ensembles in a few minutes here. So we all remember the week before Christmas, we had a major winter storm. A lot of places in southern New England had about a foot of snow, fairly close to that in many locations. But also, you remember there was that stripe in central New England, I should say, from say the Binghamton area and near Albany up into south central Vermont and south central New Hampshire, where places had 30, even over 40 inches of snow. And when you take that into consideration, the not just the snow depth, but the liquid equivalent, how much water is in that snow. Well, in southern New England, pretty good amounts, 1 to 2 inches, but a little north of our area, we had 2 to 4 inches with that heavy snow that fell, extreme snowfall, I should say. And how much of that was going to melt and go into the rivers? And remember, it's not necessarily for river flooding. It doesn't have to happen in your area. You can have, downstream impacts, obviously, from the Connecticut River. So a lot of what happens in, central New England is going to impact us in southern New England. So again, this was really well advertised several days out here from the Weather Prediction Center. 1.5 to 2 inch amounts, fairly widespread, with potential for localized 3-inch amounts. Again, and the other part of this was how much snow you're going to melt. If it was a situation where you're going to be 35 with 2 inches of rain, you're going to melt snow, but not nearly to the amount that you're going to melt with temperatures in the 50s. Not only temperatures, but dew points in the 50s, along with wind, because when you have that wind, it blows the cold air away from the snow, and it can really melt down fairly quickly. So again, we look at, as meteorologists, ensembles a lot. We're all familiar with the Jeff's ensembles, the EPS ensembles, but in this case, looking at river forecast ensembles. Basically, if you're taking, say, the GFS ensembles, and one model has 1 inch rain, the other is 2, 3 inches of rain, it's going to give you a spread into different categories. So basically, when you pull this up, yellow is giving you where there's a 30% chance of action, and then you're going up into the categories where you get to minor, moderate, and major in the purple, and then the probability of exceedance is going to be, the circles is going to be 30%, and then on the right that's going to be 70%, where you see the squares, giving you an idea of how many ensembles are forecasting a specific flood event versus confidence. And then you can actually click on those points for some more detailed information there. And as we go through here, one of the things to point out is you'll see the spread here among the guidance. So you have, the black line there is going to give you your median, the average. Where you have the clustering in the orange shading, that's your most likely range. And then you have your extreme solutions. One's taking it up to moderate flood. Again, this is the North Nashua, Fitchburg. A lot to action. What I found, and we'll go into this a little bit more, because we're taking, a range of numerous ensembles, I tend to find that it ends up verifying on the higher end of the mean so much in the tendency, is because you have very low amounts offsetting things. And especially as you get into high resolution models where you get higher amounts. So usually I kind of lean on the higher end, but again, it's obviously good to have an overview of the complete potential. And again, the Connecticut River, obviously here, because of the flow, we're a lot dependent on, how much snow is going to melt across central New England. So, how warm is it going to get? How strong the winds are, the dew points. But you see in that black line, everyone into action level pretty much, if you're looking at the general likely range there. But, fairly significant spread from numerous solutions into minor flood, a couple up to moderate, and one actually in major. And then there's a few less. So, kind of looking and evaluating that data, how accurate it's going to be compared to some other models. Remember, this is off the NACE, so if the European may be showing a different solution, you may have lower confidence in this. Whereas if the European and their ensembles are agreeing, that may give you higher confidence. So it's the same thing as applying to whether we're going to get a significant winter storm early next week based on various outputs of different models and ensembles. So yeah, this may make you a little dizzy here, but this is looking at the 24-hour individual member QPF from the Norwood area, from the European ensembles. And obviously, you're out in this time range, you're obviously seeing there is some spread here. But there's fairly high confidence that there's going to be a significant rain event. And one of the differences too, not to get off track, but when you're looking at a rain event, if the storm's going 50 miles to your west or 150 miles to your west, obviously that can affect the amounts, but you're still dealing with a significant rain event. When we're dealing with our winter storms, obviously a 50, 75 mile difference can have a big impact if it's going to our east, whether you get 15 inches of snow, mainly rain, or whatever in that varying case. So sometimes these events you can have higher confidence if you're pretty confident the storm's going to your west and you're not going to be dealing with any real threat for snow. So again, the Jeff's members here, this is for Hartford. So overall, generally looking at most of the clustering was between 1.25 and 2.75 inches. That's usually a best way to kind of get in yourself in the ballpark. Not that these extreme solutions of 4 inches or a ½ inch can't occur, but Jeff definitely giving you that higher confidence level there. And again, looking at the mean, it's sometimes easy to look at depending on what guidance source you're looking at. In this case, it performed very well, but in other cases, it may not perform so well, especially if you have if you have a lack of clustering, because then it's just averaging things out, and it could end up one way or the other. So again, that's why we're here as forecasters, to kind of piece that together and present it to the folks that need that information. So again, the WPC Super Ensemble for Hartford, generally between 1.75 and 3 inches of rain. You definitely see that clustering there. So again, if a lot of other guidance is in that ballpark, your confidence level is going to be increasing, especially as you start to get inside 48 hours. And excessive rainfall outlooks from the Weather Prediction Center, you definitely see as you kind of, and this is the goal as you get from day 3 to day 2 to day 1, you're able to add some finer detail in there and specifics there. Actually, just lost my screen for a second here. Bear with me as I get it back. Let's see, Joe, I kind of lost my screen for whatever reason here.
Okay, you need me to take over?
I'm looking for it real quick. I don't know what happened to it. I may be able to rejoin real quick.
Okay, why don't we just hang out for a second? We can do that.
Okay, let me get out of here and then.
All right, just stand by, everybody. We will resume in about 30 seconds. Always some technical glitch.
Okay, I am back.
All right, you got it, Hayden. Thanks.
All right, so as I was saying, that's the goal of this, as to kind of, as you get closer into the forecast, to kind of try to pin areas that are more likely, to experience, in this case, heavy rain and flooding from the snow melt. So as we get into the higher resolution in guidance, we're able to locate those higher amounts. And, keep in mind from the information Joe was showing you with the low level jet, remember we had really strong southeast winds. So we don't think of our areas much terrain compared to other parts of the country, but, the Worcester Hills, Connecticut Hills, those places are over 1,000 feet. And then as we get up to the Berkshires, some places are close to 2,000 feet. So you bring that southeast flow, it's no coincidence that the models are kind of pinning those areas even into Northwest Rhode Island with higher amounts. And you even see a little bit lower amounts in the Connecticut Valley. So those are things that as we get closer into the event, we can really try to nail down the more specifics. And so that was like the mean of the HREF. We really like utilizing that model quite a bit. Now, this is actually kind of looking at the HREF ensembles, but taking the worst case scenario of those ensembles. And, you'll basically see there, 3-4 inches, 3-4 inch amounts, across far Western Mass, parts of the Connecticut Hills, Northwest Rhode Island. And you actually, what it does is sometimes it can overdo it, but if you're looking up even into Maine, where you have that higher terrain and on southeast flow, they can really get hammered sometimes. And you can see those high amounts up that way. So again, based on the forecast, we had strong winds, dew points coming into the 50s, temperatures maybe approaching 60. We were going to lose, all our snow, which is what happened. Now, as you get, further north, that would become less of an issue. But the snowfall, what we consider ripe, ready to melt. So that information is going into those rivers, and that's going to combine with the rainfall and to kind of determine how much flooding we see. So this is a great satellite imagery here. Obviously, looking at this, if you have a connection right from the Caribbean all the way up the mid-Atlantic coast into New England, even into Quebec, you can see that column. So you're looking at, a tropical air mass coming into the region, over Christmas. So something like that can really, during the event or as you're, in it, really increase your confidence that, these higher rainfall amounts certainly might be realized based on this, tropical connection. This really showed up quite nicely. And another thing we look at, I know Joe showed and Frank showed earlier, climatology. So where are we in, compared to normal for this time of year? And basically we were at, P watts near 1.5 inches was basically near record levels for Christmas morning. So, obviously that's just one piece of the puzzle, but when you see something like that near record levels, well, if things are coming together, have a significant event. Obviously, P watts are higher in the summer, but you don't have the, 85 knots at 850 millibars. At least I hope that never occurs. Outside of a tropical system, I should say. So looking at the high resolution models, these really have become, great tools. It is impressive, how accurate these things can be. This was, 8 a.m. Christmas morning. Obviously, you see a large area of rain and then an embedded area of vine line, what we like to say, and that's usually indication for where we may see, obviously, not only torrential rain but strong winds too. In this case, that things didn't materialize as the potential was there. Probably a lot of it may have had to do with the rain behind it, somewhat cooling the boundary layer just enough, as Joe mentioned, but the rainfall certainly did occur. And again, looking at the 500 millibar height fields, well, you know, if you see something like that, you know, any time of year, obviously it's you know, catches your eye. You know, basically Meridiano flow right up from you know, Florida all the way up into New England. So pretty easy to see. You know, we're going to have a highly anomalous environment given it's late December and potentially a significant event. And this is actually another way to look at things, looking at the 850 moisture transport. Obviously, you know, there's many ways you can kind of look at this and come to the same conclusion, but you obviously, you know, have the big closed low to your west, all that moisture streaming up and, you know, focusing where the best convergence is. So you can see that red shading all the way up from the, you know, off the Carolina coast right into New England. So definitely a big tropical connection set up there for heavy rain. And another way to look at it too, the, you know, precipitable water column here. Obviously the drier to the west, but look at that, where that PWAT's originating from, those 1.6 to 1.7 down in from the Caribbean right up into New England. You know, values near 1.5, which for late December is pretty extreme. And one more way, looking at the deep layer moisture flux convergence, mixing ratio. Again, what do you see, that area where you have the best convergence, just sucking that tropical moisture northward, and you have the forcing along the front. So it all lines up meteorologically. Everything makes sense. This is where your heavy rain is going to be. You have your fine line, and then the rain behind it. So this was the you know, forecast versus the observed rain. And actually, one thing you want to point out, you know, we had, you know, generally 2 to 3 inch amounts forecasted, and then you see the higher amounts in the higher terrain there. And obviously nothing works out perfect, but definitely see those higher amounts tagged in parts of the Worcester Hills, the hills of Rhode Island. So definitely some utilization of the high resolution guidance. The one thing we should mention, and you know, not all the time, not all the cases, but a lot of times when we have southeast flow, you know, we tend to over forecast rainfall amounts across the Cape and Islands. Kind of somewhat maybe counterintuitive, because you're thinking, well, the wind's coming in, you know, right off the ocean, you have all that moisture, but it tends to actually focus further inland. A lot of factors at work. Obviously, you have, you know, more probably enhanced convergence, obviously where the terrain is. So that's something we see quite often. And one thing future forecasts want to make sure we at least take into consideration, not that it's going to happen all the time, but it did in this case. So this is a look at the actual rainfall for the Hartford area. Obviously the, you know, ensemble guidance, the mean, everything kind of, you know, worked out quite well. Storm total was just over 2 inches. That was what the guidance was, you know, hinting at. So, but as we mentioned earlier, the mean isn't always the answer. It can lead you astray, especially when you don't see the clustering and there's, you know, large potential spread. You know, that could be an indication. In this case, I think because we had that clustering and fairly high confidence that we'd be in that range. So again, it's taking each scenario and evaluating it as its own is usually the best way to go with these forecasts. And the actual forecast, you know, flood categories, you know, obviously you see a lot to action stage there in the, you know, yellows there, minor, and flooding in you know, a lot of Western Mass into Connecticut, parts of Rhode Island. So again, this was an indication. It all makes sense, you know, a significant snow event, a rapid meltdown, a significant rain event, but it wasn't like a 5-6 inch rain event. You know, you're talking about a couple inches. So minor river flooding was a good bet here. And then looking at the guidance and compared to how things actually verified, this was the North Nashua River at Fitchburg, just approached minor flood where you see the star, stayed just below it. But again, that's something we talked about. It kind of did fairly well, and as we often see, kind of on the high end of where the most likely scenario was going to unfold. So it was, close to minor flooding there, just below that. And then, looking at the Connecticut River, got right into solid minor flood. Again, on the higher edge of the most likely scenario there. A lot of, contributing factors with the rapid snow melt. So that when you're talking about that, there's obviously a lot of things to consider, but solid minor event there. And that pretty much wraps it up for the high winds and flooding. Fortunately, the winds somewhat underperformed. The rain pretty much occurred as expected and led to areas of minor river flooding, but nothing extreme or something that hadn't been seen before. So with that, I think I'll turn it back to Joe, who'll be handling anyone with any questions. I think you just raise your hand, Joe. Is that what?
Yeah, actually, yep. Thanks, Hayden. I've actually unmuted everybody, so if you have a question, you can just unmute yourself and go ahead and ask. Doesn't sound like anything. Going once, going twice. Just a reminder, we are recording this, so I will share the recording once I get this processed when we're done. So I will be emailing it out, the link to everybody, in case you want to share it with others at your office or your TV station. You're certainly welcome to do that. So last call, any questions? All right, sounds like we are good. So thanks everyone for taking some time out to join us, and look forward to another event review once I guess the next event happens, which could be early next week. So have a good day, everybody. Thanks for joining.